as I said, I'm just going to record the sessions that you have the chance to. Do you want to buy pizza? That you can watch it later. Now, the first thing that we do today for the start, before we just start essentially, I'm just going to walk you through before we just go for the content that I'm just going to share the PDF or let's say the PowerPoint for that. We are just going to do some simulations today, and I need everyone to install a software which is Anaconda that we can just use the Jupyter notebook from the Anaconda that you're just going to install. I'm just going to walk you through how to do that. Then I'm just going to pause the recording. I have posted also a very good video on how to install Anaconda. You can check it yourself later, but I'm going to walk you through right now to see how you can do that on the shared screen. Then I'm going to pause. You watch the video. Maybe if you do not need it, you just learn from me what do you need to do. If in case you cannot, you can just do that. Then from there, we just move on to do some simulations today, which becomes our first starting point for today. Then now, I'm just going to share my screen and I need the browser. Let me find the browser which I have. Okay, now, do you see my screen shared? I'm going to go to the Google. Now, this is what you need to do. You can it's very easy and straightforward. You are going to buy pizza? No? Okay. It's very easy and straightforward. You can just exactly learn as I move along. But if you saw some problems when I paused it there with recording, you are on your own for a couple of minutes to watch that recording also to install it. The first thing which I'm going to do, I just go to the Google. Okay. On Google, I'm just going to write Anaconda download. You see, Anaconda download, that's the thing. Oh, that's the thing which I'm just going to go through first. I'm just going to type on Google Class, not Google Class, on Google Anaconda download. Then I press the enter. Then when I do that, you see, I have done it before. You see the link has been clicked before. I'm just going to choose that one. Download Anaconda distribution. Okay. Everyone's good so far? Happy so far? It's not that hard so far, huh? Now I click on that link. I click on that link. You see this screen shows up. First, for the cookies, I'm just going to accept all. It doesn't matter. Everyone is in this page, distribution. You see that? Distribution, free download. Now you have two options. First, you can put your email address over there and press this and agree to receive communications from Anaconda. Then press the submit, go for installation. Or you say, no, I don't want to receive any emails in my mailbox. I received enough emails from the college. Then you just go, you see at the bottom, you see the submit, the green one. At the bottom, it's what skip registration. Then when you are there, you just press skip registration. Then it takes you to here, to the next page. You see? When you are here, you see that there is some operating systems that you can download Anaconda on that. Either you're using Linux or Mac or Windows. There is for all these operating systems, there is a distribution for Anaconda. You can choose anything. Now, I'm just going to go, you see that this is this kind of stuff. I'm just going to click on download, the green button. You see? When I click on download button, something jumped. If you can see my browser, you see on the very top right, you see the browser, you see the cursor, you see something, one download in progress. It goes over there, it takes a little while because that's a heavy download that it takes. When it is downloaded, I cannot share that screen because I tried that, it doesn't share that. But when the download is open, there is an exe file. It means that the file, which is this is .exe, you have to double click on it. An option opens. A window opens. You know what to do? Have you downloaded something before? You see what you have to do? Always press next, 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 finish. That's what you need to do there. Nothing to do. Any window shows up, you close your eyes, put your right finger on the mouse, press next. Next, 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 all the way till the end that it comes finish. Then it means that you have downloaded Anaconda. Okay. When you download that, it is going to be installed on your laptop. Then you need to access that. Okay. When you access it, you're gonna have, I'm just gonna stop sharing from this screen. I'm just gonna go with the sharing with the, I'm gonna share the Anaconda itself, which I have it open. Okay, now when you install everything, when you install everything, what you need to do is that you go to the start and search Anaconda. It's normally just at the very top because it comes alphabetically. Anaconda starts with the A. Then you see the first program that you have on your start menu, which you have installed on your system. When you open it, you see this menu. Everyone sees the screen which I have shared? Yes? When you see this one, you get to this menu. For this menu, you see they have, you may see not all of them, but you see for sure something which is called Anaconda. Sorry, Jupyter Notebook, which you should see launch. For some of the item, you see that the folder is there, the icon is there, for example, like R Studio. You see at the very bottom? For some of them, you see the R Studio shows there. However, it is not ready to use. You have to cook it. Like you just go to buy grocery, you have to cook it to eat it. That's what you need to do. You have to press install. It takes some time. When you install it, that you are fine. But however, for Jupyter Notebook, you see that this is already installed. It comes with the button. It's called launch. What you guess you are going to need to do? Launch it means that you started it. I'm just going to press launch. When you press launch, one of the browser in your system is going to open that. Okay. I'm just going to stop the share because now there is a browser, Internet Explorer, opened on my system, which shows that this is Jupyter Notebook. I'm just going to stop sharing up the navigator over there in order to share another screen, which is going to be the Jupyter Notebook, which I opened it. Okay. Do you see this screen now? Yes? Now, guys, I'm just going to walk you through. Then I'm going to stop the pause. Then you can do it on your own. If you run into trouble, I'm here, and also the video, which is posted on the Google Classroom, it walks you through. When you are reached to that window, it means that welcome to the Jupyter Notebook. You are ready to use that. I'm going to talk about that there. Whenever you see this, something like that, it shows Jupyter at the very top, and you see file, view, settings, those kind of stuff. These things that you see, these are my homeworks, which I did it myself. These are Jupyter notebooks, which I did work before there. It is saved there. But when you start to work there, you see this is almost empty. Huh? But in order to start it, you have to create, let's say, for example, look at that. You see these buttons here on the right, new, upload. If you want to start writing the first code, which we're going to do today, I'm just going to press on new. You see the first option, which it shows. I have a couple of options open on the drop-down menu. The notebook, terminal, console, new file, new folder. New folder, you can create a new folder over there. But the thing which I need to do, I'm just going to open a new notebook. And it means that it connects to the local host, which you have there. And do you see this screen? A blank screen opened. Python 3. Yes. I'm going to press select. And now I am just ready to use Jupyter Notebook for simulations. Then it takes only one step. You have to search download Anaconda on your system. Then the rest of it, which we did, becomes very straightforward. Now, you know what's the time for now? That you get your hands in action. And the time for me is that, take a nap. I'm just gonna stop sharing and pause the recording. Okay, before I show you the thing that the Jupyter Notebook that you downloaded, specifically from the next week, we are just gonna use extensive use of it. Okay. But before that, the thing that I'm just gonna do is that to give you some very single notes, we are gonna use it from the next week. And that's about a neuron. Then from a neuron, we are just gonna build an artificial neuron today to do some analysis. Okay. Now, look at that. Everyone has done biology too, or from the prior courses you did physiology, and everyone remembers what was a neuron. Do you remember? Look at this. Share the screen. You see the share the screen? We have two pictures. The first one on the right and the one on the left. The one on the right, you see that's the physiological neurons. You remember from that biology too that you sense the environment through the chemical signals from the environment. At the dendritic sites, the physical, the chemistry, it causes the depolarization. You sense the environment. And from the axon helix, because of the sensations that you had, you just start the depolarization of the membrane potential, which is at the resting membrane. If you remember, it was around minus 70 millivolts. Then by having the ion channels, if you remember from physiology, two ion channels, as the sodium opens, the sodium flushes inside the cytoplasm, it brings more positive charges inside, then you are shifting the minus 70 millivolts of the membrane potential, bringing it up and up and up. Then when you reach to a threshold, I'm just going to emphasize on the word threshold, which is 0 volts, you are guaranteed you fire the action potential that it goes synchronously along the axons to reaches at the synapse, that neurons are connected, and at the synapse, through the collaboration, I should say, with the calcium ions, you see the vesicles, which they had neurotransmitters inside, they're just going to burst out and diffuse the neurotransmitters like acetylcholine inside the synaptic cleft. And the neighboring neurons is going to get those neurotransmitters to send the signals, and the signals propagates. Remember that, huh? Now, and when you put all the neurons together, you have, let's say, a network of the neurons. Sometimes you call it, let's say, in the physiology that you had this kind of stuff before. Now, today what we're gonna do, I'm just gonna do that as quickly as possible. Okay, we just extended other stuff. I just want to show you kind of a demonstration today. Next week we spend more time on it. I'm just gonna build the same neuron, which it was a living physiological neurons artificially. What does it mean artificially? It means that I do not need to just have, for example, biphospholipid membranes with the axons, helix, with the cell body, those kind of stuff, dendrites. I'm going to build it on the computer, and I'm going to call that artificial neurons. What is artificial neurons? Is something that you have it in order to, for example, make decisions. You use your own physiological neurons for cognition, for feelings, for emotions, for thinking, for cognition, decision making. And I'm going to do the same thing with an artificially built neurons, except for the feelings. Okay? Now, that's a cool idea. You build an artificial neuron to feel something. Now, I'm going to come over this slide. Over this slide, you see that what we have over there is, hold on a second. Do you still have this screen shared? Okay. Now, then you see that. Now, this is a very simple thing. I just want to show that to you. For example, over there, you're going to see that a cartoon of an artificial neurons that we call that perceptron. Today, we're going to focus on the perceptron. Then next week, we are just going to stack the perceptron or artificial individual neurons together to build a neural networks, okay? Which it becomes computationally more powerful. For example, imagine that you see sometimes in the vertebrate, you see that the brain size, part of the central nervous system, implicates the strength of the cognition. Huh? For example, imagine, for example, your brain size with the brain size of a mosquito. What the big difference is that? Can a mosquito has a low level of neural connectivity like your brain to, for example, think of future? Field. No, this is less. It's the building blocks of a mosquito brain is more primitive. And that happens, like, for example, with the neurons. If you have one cell as a neuron, as an artificial neuron, it is less capable than having a huge connection of the neurons that they are well connected to each other. Huh? And that's the thing. Now, what we are going to do today is that over there with a single neuron, for example, the thing that you see on the left side, it's just a schema, a cartoon of a single neuron that you built it. How it works. For example, you see that you have some, for example, features coming 1, x1, x2, xm, with the weights w1, all the wm goes to something which you see as sigma there. This is a single neuron. It means that you are sensing the environment. For example, x1 all the way to the xm, which you are going to see that on the codes which I'm going to run today for you, which we call them the features from the outside. What is the outside environment for an artificial neuron? The outside environment for your neuron was what? The chemical environments in your, let's say, in the interstitial fluid inside, let's say, around the, for example, the cell. But the environment for artificial neuron is the data that you inputted there. For example, the features that it has. For example, if you are looking for a house, to buy a house, for example, you want to predict the pricing of the house, the features of the house, for example, the neighborhood, the number of the bedrooms, the number of the bathrooms, square feet, number of those, for example, which floor, it becomes the features. These are the features that the artificial neuron is going to sense rather than a chemical environment that comes from the physiological neurons. Then, for example, X1, X2, XM, these are the dendrites coming from the features of the data that it goes to the single neuron, which is a perceptron there. Over there, in the physiological neurons, what did we have? In the physiological neurons, what did we have was the neurons were what? They were essentially had we were causing the action potential. And the building blocks for that was having a threshold. We had a threshold, then you were guaranteed not to degrade the potentials, but to create a spike that propagates along the axon to reaches the synaptic cleft, to let the neurotransmitter be released. Over there, we do not have the threshold because we are not physiological neuron case. Then in that case, we are looking at something that you see, I called it nonlinearity. You see that? The nonlinearity written there with the circle, which is, what color is that? I'm color blinded, I guess. It is yellow. With the yellow, then you see that over there because nonlinearity. We're going to talk about that next week. We call that uh, activation functions. Then we mathematically recreate the threshold. You're going to see that next week. That any features that comes through your neuron, in order to cause it to propagate, you induce nonlinearity by a math formula in order to let it reaches the threshold to guarantee you have something at the end. Then at the end, you see that you created something. Y hat, you see, with as an output, you can, in physiological terms, this is the neurotransmitters that you, for example, you release from this neuron to the neighboring neurons. Okay. However, there is one thing. There is one thing which I wanted to go to this slide to show that to you before we come back. Now, okay, now let me continue. Now, on this slide, you see, we had one neuron before. Guys, imagine that. If you have one neuron in your brain, in your skull, imagine everyone touches your skull. Everyone touch your head. Everyone touch your skull. Don't be shy. Touch your skull. Touch your skull. Everyone touch your skull. Oh my God, it's so fun. You touch your skull, you see the hue, you see the volume there. It means that the volume of your brain, the soft tissue there. Imagine inside your skull, there was only one single individual neuron. Could you have been as functional as you are right now? No. Then as a result, you see that if you have one individual perceptron for decision making, it is not going to be as powerful as you stack many neurons like your brain. Then as in this slide, you see that counterpart. You see that you have stacking of the neurons on top of each other, that it builds it. We're going to talk about that next week. What is that in details? But look at this one as your brain, like a cartoon of your brain. You see, I have one input layer. I have first hidden layer, second hidden layer, output layer. It means that there are different individual neurons connected. But guys, remember, they're almost done. I cannot show you the codes because the time is over. We spent so much time today for the installation of Anaconda. Next week, we do not spend the time. We can save it to do more cool stuff. Okay? Now, however, remember, in your brain, in the physiological brain that you have, the neurons are connected all together. How they get connection? Through synaptic connections. Each axon boutons connect with the dendritic sides of the other one, then become synaptic cleft. And that's how they communicate. Communication of the neurons in your brain is so essential to form your cognition. If your brain doesn't communicate from different parts of the brain, there is no cognition. Then as a result, the neurons that you stack on top of each other, they have to be able to communicate. But the communication doesn't come like that. For example, like this synapse sends the vesicles of the neurotransmitter at the presynaptic clefts. The calcium ion causes the release of exocytosis. Then the neurotransmitter connects you with the other one. Over there, the neurons becomes connected through a weight. Are you listening? I think this is too loud. We have 5 minutes left only. Let me do the, oh my God, it was too loud. Oh my God. I know why I got headache then. It was just because of that. In the physiological neurons, the brain connect the cellular connected like that. But in the artificial neurons that you build, for example, to make a decision, this semester, the path that we're going to take all the way to week 15, we're going to talk about the generative models, which are part of the neurons that you make. These models are so capable that you're just going to look at one practical applications that you're just going to design a drug, okay? And we call that de novo drug design with the generative methods. We're going to do incredible stuff that the human beings, even they cannot do that. Then as a result, we have to have huge number of neurons that they connect and communicate. The communications over this slide that you see is done through the lines. You see, for example, the first hidden layer, the number one N1 connects to all the neurons at the second hidden layer. Huh? You see that? Then this one, it means that this is what? This is essentially the connection between one neuron to the other one. This line. But this line not only represents the direction of the connectivity, but the connection happens by one digit. There is a number. You're going to see that next week. We call it weight. It's somewhere between 0 and 1, a positive number between 0 and 1, that it shows the connection between these two neurons. If the number comes to be 1, we call that weight. It means that these two neurons, they're talking to each other all the time. They are making themselves get a headache. If this is 0, it means they do not talk. They had a fight, they do not talk. Then that number, which is called weight, in this slide, I don't want to go through this math today. Look at this slide, the weights W0, W1, W2. These are the weights, shows the strength of connection between the adjacent neurons. That's how it works. However, as a final thing that I want to discuss before we just talk next week more about that. As a final thing, I'm going to talk. The final thing is this. Let me come here. Look at that. How much? I need 5 minutes. Don't cry, guys. Don't cry. We can meet each other next week again. Don't be sad. Now, the very final thing which I'm going to say is this. That, guys, look at that. Look at the fan was running. What it was running over there. Now, because you have a very well-developed cognition, you can think of it. I'm going to ask you one simple question. What happens if I look at my fingers? Everyone can see my finger? When the fan is running, I'm just going to put my fingers inside the fan. What do you expect is going to happen? What do you expect? Huh? Huh? Are you laughing? I'm going to look at that. When I put my fingers, oh my God. Call 911. Huh? But imagine, I put my fingers in there. You need the natural, I just, yeah. Now I've got to put the fan on. Imagine if the fan is on. She wants to kill me. You have to repeat the course again, my friend. I'm going to fail you. I'm going to fail you. Now, imagine I put my fingers when the fan is on inside the fan, then naturally, instinctively, you see that I'm just going to drag my hand, put away my hand. But that's the natural thing. But imagine I put my hand over there because my brain knows how to react. Because when I put there, the sensory neurons, mechanical receptors, takes this, send it to the interneurons, comes to my brain, the response comes back to afferent neuron, then my hands just shuttle muscles take away my hand. But this is a very important thing, and I'm going to finish the lecture by that. Everyone listen very carefully. But imagine I put my fingers inside the fan, which is on, and I keep my fingers there and I start laughing. Ha, 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 ha. Then this is natural. This is not natural. This is not the expected response that you need. Then the more pain which I feel, the more pain which goes to my brain starts to learn, oh, maybe there is a better option than laughing. Let's put my fingers away. This is called in neural networks feedback and back propagation. That's what we have over there. And that was a very cool example to see how it works. When you train your model and you expect a response. You know what is the response now? The response is that to put away your hand from the fan, which is on. You know, this response is very logical. But the time that your brain starts to learn this logical response, through the pain that you feel on the top of your finger, this is a back propagation feedback. Means that the more pain which I get, the more signals it gets to my brain, then I feel, oh, pain is a bad thing. Let me think, what other option do I have? Do I have to put my fingers more inside the fan or push it back? You see, but naturally I learn it. I put in quotation this word, learn it to put away my hand. That's how the neural networks learn this stuff. You see next week more in depth. Then whenever you train a model, based on the distance of the expected result and what you receive, you are going to create something which more technically called that loss function. The loss function which I had over there was the pain which I was enduring. The more pain I got, the more I learned to draw my hand away. Then it was a back propagation. Then in the context that we had, for each back propagation, I regenerate the weights. The weights, they govern the learning. The W, which is between 0 and 1, They control the learning, and my learning happens through them because they govern the connectivity of the neurons and the way which I learn efficiently. Then again, another set of the weight is created. My learning gets improved. Then I see, oh, the distance which I took away my hands from the fan was not enough. Then it's better to just move further back. Then I learn it as much that completely my hand is out of the fan. And that means that my learning reached to an optimal level. Next week, this is what we said. It was a kind of a blah, 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 blah story of what a neural network is, what it does. The codes which we had today for simulation, we are a little bit around out of the time. We cannot do that, but the good thing is that next week, we have our system all running, then we can jump into some simulations besides from some theory behind it. Okay? Now, speaking of which, I'm gonna ask if anyone has a question. No?